Hello everyone, welcome back. So these are the few theorems which we have done in the previous video related to circles and the chords. The first theorem, the statements equal chords of a circle subtend equal angles at the center. It means if there are two chords which are equal in a circle, then the angles formed by them at the center will be equal. Next is just the converse of this. If the angles subtended by the chords of a circle at the center are equal, then the chords are also equal. Here it says if there are two chords which subtend equal angles at the center, then the chords will also be equal. Third, it says the perpendicular drawn from the center of a circle to a chord bisects a chord. Now, here it is that from the center of the circle, if we draw a perpendicular on the chord, that is to a chord, then it will bisect the chord. That is, it will divide the chord into two equal parts. Next is the converse of this. It says the line joining the midpoint of a chord of a circle to its center is perpendicular to the chord. So here, if there is a line which is drawn from the center to the midpoint of the chord, then that line segment will be perpendicular to the chord. Next, there is one and only one circle passing through three non-collinear points. So if you are given three non-collinear points, then we can draw only one circle which passes through these 3 points. So these were the statements, the theorems which we have done. Now let's move towards the next. The next theorem is 12.6. It says that equal chords of a circle are equidistant from the center. Equal chords of a circle. It means if there are two chords which are equal in length, then they are equidistant from the center. Means they lie at equal distance from the center. So given, as you can see here, there is a circle where chord AB and chord CD, they two are equal. Also, OM is drawn perpendicular to AB and ON is drawn perpendicular to CD. Why perpendicular? Because we need to prove that they are equidistant from the center. So, distance of a point from the line or a line segment is the perpendicular distance taken. So, the perpendicular distance which is that is OM and ON. So, we have to prove that these two are equal. So to prove OM equals to ON, construction, in order to prove it, we will join OA and OC. Any of these can be drawn. So after joining these, now we get two triangles. So take the two triangles and try to prove them that they are congruent. So if you see here, we have chords equal. So AB is equal to CD. But in the triangle, AB is not included. What is included? AM. Whereas in the second triangle, in place of CD, CN is included. So we are given that AB and CD are equal. Now, can we say that AM and CN are also equal? It can be, because say OM is perpendicular to AB. And just now we have done the revision of the previous statements. So according to that, what you will have, the perpendicular drawn from center to the chord bisects the chord. Now because perpendicular drawn from center to the chord bisects the chord. Therefore, AM and MB, they are equal, and if these are equal, then they are half of AB. Similarly, ON is perpendicular to CD. Therefore, CN is equal to ND, and these both are half of CD. Right? So now we have AB is equal to CD. AB and CD are equal. Now if these are equal, then half of them are also equal. If two line segments are equal, then their half will also be equal. And because half are equal, half of AB is AM and half of CD is CN. So this shows that AM is equal to CN using first and second. So ultimately we get that AM and CN, they are equal. Now I think you can easily prove that the triangles, they are congruent to each other. So have the triangles. In triangle AMO and triangle CNO. Taking the two triangles, what do you have now? Angle AMO is equal to angle CNO, each 90 degree. Also, AO is equal to CO. These two are also equal. They are the radii of circle. Both are radius. And you have AM is equal to CN. This we have proved above. So with these three conditions, one right angle is there. This AO and CO, they are the sides opposite to the right angle, means hypotenuse is equal and one side is equal. Therefore, the two triangles, they are congruent. Therefore, triangle AMO is congruent to triangle CNO, and this is by Rhs Congruence Rule. Now triangles are congruent, so of course their corresponding parts will be equal. So the corresponding parts OM and ON are included. Hence, OM is equal to ON. This is the corresponding parts of congruent triangles. So hence it proves that if chords are equal, then the distance of the chords from the center is also equal. Or in simple words, equal chords of a circle are equidistant from the center. So this is clear, a simple theorem. And now let us move towards the next theorem, which is just the converse of this theorem. So the converse, theorem number 12.7, it says chords equidistant from the center of a circle are equal in length. If there are two chords which are equidistant from the center of circle, then it means they are equal in length. So here what is given? We are given that chords AB and chords CD are situated at equal distance from the center. That is, OM is equal to ON. Now this is already given to us. And what we need to prove? We need to prove that the chord AB and chord CD, they are equal in length. So again, in order to prove it, we will have a construction. We are going to join OB and join OD. These two line segments will be joined so that two triangles are created, and now we will prove these two triangles congruent. So in proof, in triangle OMB and triangle OND. Now consider the two triangles. In these two triangles now, you can see here what parts are equal. So what do you have there? You have angle OMB is equal to angle OND, each 90 degree. OB is equal to OD, radii of circle. OB and OD, they are the radius. Then OM is equal to ON, that is, what you will say, they are given to us. So with these three conditions, one right angle, one hypotenuse and one side, triangles are congruent. So triangle OMB is equal to triangle OND. The triangles are equal in the sense they are congruent, and they are congruent by which rule? RHS congruence rule. Now because these triangles are congruent, so their corresponding parts will be equal. Now corresponding parts in the sense MB is equal to ND by CPCD. Now MB and ND, they are equal, but MB is half of AB and ND is half of CD. Now why they are half? Because again here OM, this is the perpendicular drawn from center to the chord. So this OM will bisect the chord AB, because perpendicular drawn from center to the chord bisects the chord. And same way ON is perpendicular to CD, so ON also bisects CD. Hence we have that M and N, they are the midpoints of AB and CD. So just because of this property, or say the theorem, MB, it is half of AB and ND is half of CD. Now if these two are half of it each, then we say, because MB and ND are equal, MB it is half of AB and ND it is half of CD. So what you have? You have AB upon 2 is equal to CD upon 2. Now if half are equal, then the whole will also be equal. So AB is equal to CD, and this is what we had to prove. So what it is proved here now, that if there are two chords which are at equal distance from the center, then it means the chords, they are also equal to each other. So for today, this is our In the next video, we'll continue with further topics related to this chapter. Till then, have a nice day. Enjoy all. Jai Hind. And before leaving, just don't forget to like, share the video. Thank you all.